Tsú-thuàn. If you don't understand Taiwanese, then you can call me Danny. Today, I'm going to present macro as type. Macro as type? What does that mean? It means we let list code become this. As you can see, the conversion is quite simple. The key idea is reusing the environment of macro to store information of types. That is why we have defined for syntax to bind name with type and have defined to bind name with value. But how? First, we can take a look at simply type. As you see, in simply type, we check the expect type same as the type of expression and return the conversion. And here, type of is a helper. Let's take a look. Type of basically only care about literals, and eval rest of possible syntax. The power of this will show in the next example, function. We let function become this. Now we need to check the type of function body, but how to get parameters? Since we use eval, the task has been easy. Introduce let is enough. Here is our inference for function body. Above shows the ability to create a new thing. Time to talk about interacting with the old thing. Claim is such functionality. From what you see, the claim is just binding at type level, nothing more. Let's see an example. As you can see, here I claim add1 as number to number. Then apply string to it would cause an error. The next is generic, or type-free variable if you're familiar with type theory. Here is a classic identity function. Expansion as simple as a normal function. The only interesting part is the following check. As you see, we only need one more latch to introduce free variables for unification in the checking. The last thing is arbitrary length parameter. It only stands for parameter that is promised when constructing function type. When applying it, it will automatically be extract and fit the length of the argument before unification. For example, applying here has a list 1, 2, 3, and application part will expand it to number to list of number. And then if you change 3 to a string or a boolean, then it will cause a type error because that is not a number. That is a mean of automatically extract. Now we have enough understanding about the syntax and conversion. We could have some core functions. Unification is the most important one. Unification is a simple process. It repeatedly asks, can type A be unified with type B? In this type system, this talk, 4 conditions need to be considered in unification algorithm. First, unify free variable with type, or unify type with free variable. In this situation, unbound free variable can unify with anything. We only need that as a type. Or free variable bound can unify with unbound free variable, or bound free variable that bound same thing, or the bound itself. Second, function type with function type. Function type ensure another type is a function type first, then unify with it by checking every parameter types are same by unify, then check return type are same also by unify. Third, higher type with higher type. Higher type is the type depends on type. For example, list of A is a type if A is a type. But list is not a type, but a type constructor, or sometimes we call it type family. Notice that function type also is a kind of a higher type. As function type, we check names are same first. Then we check all elements type are same by unification. Fourth, type with type. In the last condition, we only need comparing them by equal. If they are not same, then we raise a syntax error. Time to talk about limitation. The third thing we could be noticed might be dependent type couldn't use such technology. As this not directly used, the problem is, for example, we have a data net here, but then we would need to bind type and bind value in the same level. For example, how can we to decide we need to define for syntax 0 bind to net, or define for syntax 0 bind to 0. Another limitation was conflict. In our type of helper, eval seems to solve all problems. However, not that easy. To check application in defined form, eval would raise apply on non-procedure exception, of course, because application would be a type, a function type. But function type is not applicable, it's not a procedure. To solve this problem, we need to hijack application form. However, this would also hijack the let binding we used previously. Therefore, we need to escape let form to help generic and parameter where we use let work correctly. By the way, we also escape lambda form because we actually also can use lambda and define variable form to do the same thing, just like define function form. And provide type-free variable for inferent type of the lambda form. Of course, because every lambda is a no type, or it bound to free variable. and then we unification with its type in the defined form. In the future, I will keep digging about how to reusing module, or can we support dependent type, and can we solve conflict in a better way, not like the current escape solution. Okay, this is the end, and you can get more information in the link. Thanks for listening.